worst case, at least some of the infrastructure monitoring, you might be doing it, or it might be done by the other teams as well. Depending upon the project to project, it might vary. Depending upon your experience also, it might vary. Right? In some of you might be just doing execution and scripting. The analysis and reporting will be done with the senior folks. So you might be falling under various of these category, right? So what we wanted to do from this course is to transform yourself so that after taking this course, after you do the hands-on, right? You need to remember two things. One, you need to learn whatever I'm going to teach, and you should also practice once at least whatever we learn, right? After the day or in the weekend or whenever you get time within the 2 to 3 months, you should at least practice everything on your own in your machine. Okay, and don't worry, whatever softwares we are going to use, whatever tools we are going to use, whatever you're going to learn, you would be able to do hands-on by yourself in your laptop. Okay, either it is going to be an open source tool, or even if it is going to be a commercial like Dynatrace or AppDynamics, you would be able to register, and then you would be able to use it with a trial account. Definitely, it's not like you won't be able to do anything. You will be able to do everything what I do. You will be able to do it on your laptop. Okay, we will try to enable you on those aspects. Okay, but it's your responsibility to practice it at least once, so that after 2 months, after 3 months, once you learn and practice, you would be able to do all these things on your own. Not that you are going to become an expert, right? But it is for you to kickstart your performance engineering career, right? So you would be able to know what is client-side profiling and server-side profiling. You will be able to go and do this on your own using tool like JProfiler for server-side profiling, using the developer tools for client-side profiling, and few more techniques in terms of optimizing the client-side pages. So you would be able to do all this on your own, right? Part of your early performance engineering. And during a test, depending upon your the test behavior, depending upon the memory pattern, depending upon the CPU pattern, you would be able to go and take the heap dump and thread dump, and then you'd be able to analyze the same as well. And you would be able to go and get the AWR report from your DBS and analyze from an application performance perspective. You should be able to comfortably use the tools like JConsole, JVisualVM, JProfiler for your monitoring and profiling. Right? When it comes to benchmarking, when it comes to JVM tuning, JVM configuration, you'll be able to go and perform various tests, and you should be able to recommend, you should be able to set the parameters for your heap, your thread, and your GC parameters. Okay. And if you're already using any monitoring tool or APM tool, which is good. If not, you would be able to use a tool, any of the tool, right? Either AppDynamics or Dynatrace, and then you should be able to do a deep dive diagnostics, right? So there are many APM tools like Neuralink, you have Azure Insights, you have AppDynamics, Dynatrace. Every tool from a feature perspective, it's going to be same, right? It's going to, you would be able to monitor, you would be able to troubleshoot, you would be able to do a diagnostics, right? So it doesn't really matter what tool you're going to use it, as long as you will be able to use one tool and to perform these things, you will be able to easily scale to other tools as well. Right? Your performance testing tool, performance engineering is going to be tool agnostics, right? So you cannot go and master the tools, rather master the concepts. Okay. So whatever tools we are going to use it, it is going to be a representative of that. But say for example, if you know LoadRunner, you'd be able to easily scale to a NeoLoad or a Jmeter, right? Similarly, if you learn JProfiler or if you learn AppDynamics or other tools, you'll be able to extend it for other such similar tools as well. So don't you should not always try to master every other tool. Try to learn one tool, and then depending upon the project, depending upon the tool that they are going to use it, you'll be able to expand it little easily, right? So all these things is what you should be able to do it on yourself, or you should be able to go and claim that you have a capability skill set in all these areas in your when you go to a new project or when you go for an interview. And when a person who is going to listen to you, interview you, a performance tester, versus when you're going to add all these skills, you're not going to false claim saying that you have experience in all these areas, right? We are never going to do it. What you're going to say is you have a exposure, you have a hands-on on all these engineering areas. You can probably say probably a 6 months or a 1 year experience maximum, but on engineering, right? But when it comes to the package of combining this testing and engineering, it would put yourself up in a very good position when they compare you against a normal performance tester, right? That is the whole idea, to differentiate yourself from the other performance tester. And it's not going to be a false claim. You're going to learn, you're going to do an hands-on with an actual application, and which means you can go and confidently say that you will be able to do all these when you got an opportunity, right? So when it comes to performance engineering, it's going to be a combination of multiple things, right? One is your testing, of course, your whatever you might be already doing it, like your NFR gathering, your scripting, execution, analysis, and reporting, right? That is still going to be a good chunk of work when it comes to performance engineering. Along with that, um, there are two small areas. One is your programming, and another one is going to be your um, networking administration. Right? So programming as such, we are not going to um, the boundary of a performance engineer in most of the places, at least for a 2 year, 3 year, 4 year performance engineer, is to provide the analysis and then provide the recommendation. It is not the code fixes. It is not the exact code level recommendation, right? It is more about your observation. It is more about analysis. It is your recommendation on what can be done. It's not a actual code fix or actual pinpointing. This is a line of code. This is the way you need to change it. That is not going to happen in the first year, second year, or third year, right? And we are not the Java experts or Python experts. We are not a developer, right? We are not going to go and write programs. But it is good to learn the concepts of the program, what developer might be doing it, so that it won't be a black box, right? As a performance tester, you would be restricting yourself to saying your transaction is having high failure rate, or your transaction is having high response time. You'll be talking at a application level, a transaction level, a page level, right? But when it comes to performance engineer, you'll be talking more in terms of you have a issue in this method, your object is having a problem, your time is spent in this class file in this method. So it is kind of a developer terminology is what you will be speaking about, which means it is good if you know little bit of the concepts around it, little bit of what, right? It should not be complete black box. So if it is a Java, you should know about how a Java program is going to get structured, what is class, what is method, how a method is building invoke from another method. Very high level basics of a programming is required, so that you can go and confidently go and speak to the your developers, right? So I'll come to that part a little later. We will have a topic to begin with, to break that shackles, right? We should not feel ignorant. We should not feel less confident when we go and talk to the developer. So we'll have a day or two's topic on um, think like a developer, right? We'll go and write few programs. Even if you don't have any knowledge, that is absolutely fine. We'll just going to do a basics of programming for you to get out of that mindset. Okay. And a little bit of networking administration is required. So in today's world, you're not going to have somebody come and install tools, come and install software, right? They will provide the missions, or you're going to go out and spin up your own missions, install all the softwares, your tools, and you have your own environment, right? So you should also be very hands-on, comfortable in setting up the tools, setting up the softwares, installing it. So all these administration is required in today's world. Okay. And then comes your system analysis, which is going to be combination of all these things whichever I told from an engineering perspective, right? You should be able to review the architecture, review the design, not as a 1 year, 2 year, 3 year performance engineer, but as you gain experience in this field, it is very important to review the architecture, review the design, because if there are design flaws, whatever you're going to profile, whatever you're going to analyze and then provide recommendation, you will not be able to meet the business response time SLA or the expectation of the business, right? So there might be multiple hops, multiple components in an architecture, which will never going to allow you to have a login responding within 3 seconds or 5 seconds. So it's very important to review the architecture, review the design, um, to make sure that it will meet the business requirement to a certain level, right? And then developing this engineering strategy, right? What to test, when to test, what tools are we going to use it, what approach we are going to follow. So you should be able to, similar to a test plan, you should be able to create an engineering plan or engineering strategy as well. Okay. And then as part of the early performance engineering, you should be able to go and look into the deployed features. It could be a microservices, it could be a your UI feature, right? You should be able to go and do the both server-side profiling to optimize the response time, to find out if there are any memory leaks, and then provide recommendation. Server-side profiling will involve both CPU profiling and the memory profiling. And then a client-side profiling more in terms of optimizing your web pages. You should, as a performance engineer, you should be able to do both of these things. And then before going into the actual execution, so all these things will happen before the actual test execution phase, right? It's part of the early performance engineering. And then you should be able to benchmark your JVM in terms of capacity. You should be able to go and run iterative test with various configuration of your thread, your heap, and then find out whether your response times are meeting the SLA for a given configuration in a JVM. That's what we call it as a benchmarking, right? So we should be able to do a benchmarking and provide the optimal configuration for a JVM. And during a test, you should be able to, or one more step is you should be able to create a monitoring strategy, making sure that every component is monitored, observed, so that when you do a test, you should be able to get all the critical, important performance metrics from every component. See, the whole effort that we spend to create the script is to do the execution. But why do we need to do execution? To make sure that your response times are good, your servers are performing in an optimal way. Unless otherwise you would be able to go and monitor it, then how do you know that it is all doing good, right? So if your monitoring is not good, if you couldn't able to monitor all the component, then it's not the actual performance testing that we do, right? So the whole effort that you put into scripting and execution, it's not really going to give you a right result. Okay, so monitoring is also going to be part of your engineering role, and you should be capable to monitor using the open source tool and also the APM tools like Dynatrace or AppDynamics. And as a performance engineer or as an application performance engineer, you should be able to analyze your database interaction and then able to find out problems in the report like AWR report. We are not going to be a database performance engineer. We are not going to fine tune databases. We are not going to configure or tune your database related parameters, right? That is not, that is a DBA's work. We are not DBAs. We are not database performance engineer. We are trying to learn application performance engineering. So to that level, you have to be able to analyze your AWR report and provide the inputs, right? So all these things is what, and moving into production, you should be able to go and monitor the application performance in production using synthetic monitoring tools, your real user monitoring tools, and get a feedback into your testing as well. So all these things is what a system analysis or a performance engineering that you should know about it, right? And this is what we are going to learn as well. Whatever I have been talking about is what we have tailored to learn all these topics in this course, right? The challenge with the engineering is there is no boundary, right? There are any number of things that you can learn. So there is going to be a frequent questions coming up from the students, right? Whether we will learn this, whether we learn that. So there are many reasons we cannot bring in everything into the course, right? One, it has to be time bounded. We cannot keep on having it for 6 weeks, 8 weeks, 12 weeks, right? So the course is very tailored so that you would be able to learn everything that will make you to move from a performance tester to a performance engineering. And this base will give you a very good head start so that you can scale to whatever area you want. For example, we are going to learn about Java performance engineering. Lot of common concept irrespective of Java, like all your APM tools, your client-side profiling, your database analysis, your engineering strategy, all these things are common. But there are going to be some topics which are very specific to Java performance engineering, right? Then why not Python, or why not your Node.js? Why not .NET, right? All these are various programming frameworks and programming languages, right? So obviously we cannot learn everything, and in any enterprise architecture, you will have definitely you will have your core Java as one of the main component. And from the job perspective, from the interview perspective, and also more from the relevance of that in an architecture, we are going to learn Java and not the other programming languages for the obvious reasons. Okay, this will give you exactly in what phase we are going to use all these, what we are going to learn, right? In a design phase, what we are going to do. In a development phase, what we are going to do. So one more thing, what you need to really understand is the performance engineer is going to work along the entire SDLC cycle, right? During a requirement NFR phase, you need to work with your business analyst. You're going to work with the architecture to make sure that NFR is defined properly. And then during a design phase, you will review the architecture, you will review the design. During a development stage, as and when a code is deployed, as and when a service is getting developed, you will be doing all these server-side profiling, your client-side profiling, your benchmarking, everything, right? And during testing, you will do execution and also will be monitoring it, and then doing a heap dump, thread dump, GC monitoring everything during a testing phase. And in production, you will be responsible for creating those synthetic monitoring scripts, executing or configuring those, and then monitoring the synthetic monitoring tool and real user monitoring tool for a feedback perspective. Okay, so entire life cycle you will be relevant, right? In today's world, with a lot of focus on AI, Gen AI, scripting is going to getting automated. Automatically, your execution is going to happen, right? Which means a performance tester role is little bit getting skewed, right? It is not that it's going to go away, but definitely it is getting automated, right? So you need to make sure that you are going to be relevant, which means if you want to be relevant for the entire life cycle of an SDLC, so definitely learning performance engineering is the step forward towards that. Okay. Yeah. So what we'll do is next 15 minutes, I'll go over the topics, what we are going to cover. And then if there are any questions, I'll go into the QA. Okay. So all I was talking about for you to understand why we need to learn performance engineering and what has to be learned and what you're going to learning in the next 3 to 4 weeks. Okay. Before I go into topic, right? All these things we are going to learn the way that it's not going to be completely theoretical, right? Of course, the concepts are going to be theoretical, and then it will be aided with the practical demonstration or practical hands-on of every activity, right? So we will use a Java application connected to MySQL, okay, and we will use that for our learning. And the way it is going to happen is there is going to be an application that is going to get that is going to be available in my machine. For example, in my machine, this Java application is running here, right? And then the e-library application is what we will use it for our all our profiling and then testing execution. Okay, let me quickly log into that to show you the application. So you would be able to install this application in your machine. Okay, I will provide you the WAR file, which you will be able to deploy it in your machine. Okay, I'll cover how to deploy, how to bring up the server tomorrow. I also have a video which I'll ask the team to upload it. So with that, you would be able to have this jar file running in your machine. Okay, and then the files, war file, whichever we are going to use it for, say, response time analysis or for the memory leak analysis or the thread analysis, right? Um, so you would have the drive in which you will get access to this drive. So for every topic, you will have a folder, and then in that folder, you will find the war files or the associated files that you can download, and then that you can use it for your hands-on. Okay, so the drive access will be given to you so that you can download everything in your machine and you can set it up. Okay. Yes, so this is more of an administrative login where you'd be able to add a librarian and view the librarian. So it's an e-library application, right? So you will have two things. One, as an admin, you will be able to log in and do a few functionalities, and as a normal librarian, you'd be able to log in, and then you will be able to view the book, issue the book, view the issued book, return book. All these functionalities are there from a librarian login. Okay, we'll make use of all these functionalities whenever that is required for our hands-on. Okay, so we will deploy the file and then we will test it, identify if there is any performance problem, and then if there's any performance problem, we'll go and diagnose the problem, and then we'll also have the code for this e-library application. Right, it's not going to be a black box, though. It is not required for you to access the code even in a project, right? We may not get access to the code, so you don't need to worry about okay, I don't know Java, I don't know programs. We are not going, it's not required for us to go and touch the code at all. Okay, in most of the cases, we'll not even get an access to the code. Okay, for our learning, just because it should not be a black box, we will go and see what is there inside the code, and then we will try to see where is a problem so that you can correlate, we can able to relate the problem with the code. That is the only intention. If you wanted to set up this project as well in your mission, you can very well do it. I'll provide you the code as well, which you can import into the Eclipse. Okay, it's not going to be a super tough work. It's very simple to import these files into your mission. Okay, but again, it's not mandatory. Okay, so we'll use this code in conjunction with our the testing, and then we also will go and fix the problem in the code. We'll again get the new war file, deploy it, and then see whether the performance is fixed or not, issue is fixed or not. So that's how we learn for the most of the topics. Okay, and what we want you is to set up this environment in your laptop, right? Very, very simple. You should have your personal laptop. Um, Java, Java 8, or even a latest Java is also fine. Eclipse is optional. Tomcat, I'll provide you the Tomcat, which you can download it from my drive, or you can download it from the internet. And then the sample Java application, which I will give it to you. That's it, nothing else, right? And then as we move on, so these are the very minimum prerequisite you need, right? Your laptop, a Java in your machine, a Tomcat, and the war file which I'm going to give it. And then as we go and learn every topic, we might need few tools like JProfiler, your Visual VM, your JConsole, and then you might need for analyzing your heap dump, and then for your monitoring tools, Grafana, and few other things. Right? I'll give you all the tools are going to be available here, but that you can go and download, install as we go into the each of every topic. Yeah, everything is all very, very simple installation. Uh, Even if you're not very technical, you would be able to do it very easily. Okay, first of all, don't worry about whether I can do it or not. Right, it's all very straightforward. You'll have a lot of support in the internet, and if you face issue, that is where you will learn as well. So first of all, for you to learn, you to get transformed into your performance engineer, you should not worry about whether you would be able to do it or not. Right? Absolutely, you will be able to do everything what we learn. So have that confidence on you, right? So this is how we are going to learn these or engineering. But you will be listening it, and then you will be able to practicing it in your laptop, right? Fine. From a topic perspective, Just give me a few seconds. I'll take some water. Okay. From the topics perspective, as I mentioned initially, we will have this think like a developer to start with, right? So the idea is to not to go and learn code programming, right? It is more for you to understand what a developer will do um, from his work, right? How he's going to create the project, how he's going to create the class files, how he's going to create multiple methods. What is method? What is object? What is your class? How it is organized in an Eclipse, and then how it is getting compiled, how a jar or var is getting created. All these things is what we will learn it and so on, so that it won't be a black box for you, right? So basics of Java, basics of JVM. The basics of JVM is very important because everything is going to happen inside your JVM, right? So understanding the concepts of JVM is very important, and then the basics of Java as well. Okay, we'll go and write some programs. We'll go and compile it. We'll go and get a jar file. We'll look into how a typical web application is going to look like in terms of um, your web pages documents, in terms of your server-side code, right? And also setting up the Java environment for your service as well as for your development. So all these things is what we wanted to do it in the first day or second day, so that you will get into that mindset, right? Going forward, when you go to the engineering topics, it should not be a black box for you, right? From that perspective, we'll go and learn the Java basics and your JVM basics. Okay, and from there, um, we will move on to the engineering topics. So we'll set the base with Java basics and JVM basics, and then we'll go into the performance engineering, right? From performance engineering, there are three areas. One is your shift left, early performance, and then your during testing, and then post testing, right? That's how the topics also has been segregated. So first we will look into the uh, when you get into a project, if you're a performance engineer, what is your role, what you are going to do during the development phase, right? So we will go and look into the application that is getting deployed, the new features that is getting deployed, and then for every new feature, every major enhancements, we have to do response time analysis and memory analysis, right? See, your capacity of your machine, capacity of your JVM depends upon two major areas. How fast your page is going to perform which will be related to the your CPU time, right? If a login takes 3 seconds, if a login takes 8 seconds, which means your CPU is going to be busy for 8 seconds compared to your 3 seconds, which means a thread is going to be active for 8 seconds rather than 3 seconds. Okay, so response time, thread, CPU, all three are interrelated. That is going to define your capacity. Don't worry if you don't understand. We'll be going in detail later. I'm just giving you a preview of what you're going to learn, why we need to do this, right? So as part of the engineering, we will start with your response time profiling or CPU profiling. The reason is all three are interrelated. You need to make sure, yes, your response time is not high, uh, uh, even with a single user, right? This is single user profiling. It's a when you do a shift left performance engineering, it's a single user response time analysis, where you will take a functionality, you will use tools to understand whether your response time is good or bad. If bad, you'll try to understand where the response time is spending, right? If is it in which class file, which method, which query. So optimizing the response time is important because lesser the response time, faster a thread is going to complete its work. Faster a thread is going to complete a work, less CPU, right? That is one aspect. Second is the same page, same functionality, how much memory it's going to occupy. For a page to work, for a login to work, there will be a lot of variables, right? That will be declared in a program. It could be a string, it could be a map, it could be a whatever data type. temporarily it is going to occupy some memory, right? Even if you're going to do 1 plus 1 equal to 2, one is has to get stored as an integer, another one has to get stored in an integer, output has to get stored in another integer, right? Which means three integers will has to be temporarily stored in your memory, which means it might occupy 5 KB or 3 bytes or 10 bytes or 1 KB. Correct. So that's a very simple example I'm saying. For a login to work, it might have say 1 MB or 500 KB or 200 KB of memory it will occupy, because there's going to be n number of variables that is getting declared for temporarily storing a lot of these variables. Okay. And from an engineering perspective, you have to make sure that what is your memory conception, and once a login is completed, this memory has to get deleted, right? Whether it is happening or not. If it is not happening, that is what we call it as a leak. So from a performance engineering perspective, we will go and take the some of the features in e-library application, and then we'll go into a response time analysis and as well as your leak analysis. Okay. And when we move on from once we completed this profiling, then from a memory perspective, it's just not one factor. We'll go and learn couple of detailed topics, your Java stack, your Java heap from a concept perspective. You might have heard about Stack Overflow, right? We'll try to learn few things about Stack, what issue can come from a stack. We'll try to practically see it, and then we'll look into the memory leak analysis, heap dump analysis. We'll learn how to take a heap dump, how to analyze the heap dump, and then garbage collection concepts, how to monitor your garbage collection, what are the various components of garbage collection, various collectors, what are the various tuning flags. All these things we are going to learn from a Java memory perspective, right? 4 to 5 days comprehensive learning of your Java memory, heap, stack, heap dumps, and garbage collections. Okay. Then the other component is thread, right? Your response time, your heap memory, GCs, and then third is going to be your thread, right? So from a thread perspective, again, we will go and learn what is Java thread, and how do we configure the Java threads, what can go wrong with when threads are thread count are low, or when the thread count is high, what are the thread contentions, what are the issues that we will face during a load testing from a thread perspective, and then when to take thread dump, what to take thread dump, how to take thread dump. All these things we will learn from a thread dump analysis. Okay. Again, we will be using multiple tools along with our e-library application. We'll be running a small test, and then we'll be monitoring the CPU, and then taking a thread dump and then we'll be go and analyze the thread dump as well. Okay. There are going to be specific problems that will be available in application with respect to threads, with respect to memory, so that when we go and run a test, right, we will be able to look into the issue and then take the dumps and then analyze it and then go and fix it in the code as well, and then go and do a retest. That's what we're going to do for all these topics. Okay. Yeah. Once we learn the response time, your Java memory and thread, then we will touch upon the client side performance engineering as well, right? All these things, whatever I told, it's all server side engineering. It is equally important to analyze your client side web pages, find out problems, and also provide the optimization. So we look into how to monitor the client side metrics, how to test it, and what are the metrics we have to look into it. The things like your time to first paint, time to first content will paint, your onload time, your speed index. So all these things we will learn from a client side perspective, and also we'll go and see how to optimize your web pages in terms of reducing the size, reducing the number of requests, JavaScript minification. All these things we will learn from a optimization. Okay. And I'll also provide an introduction to how to automate the client side performance. But there is also going to be a 6 to 7 hours of video that will be given to you from a Selenium integration with your client side performance to automate your client side performance. Okay. So from there, we will move on to monitoring. Okay, so we'll try to learn the monitoring strategy, how to create the monitoring strategy, why it is important, and then um, how to create the strategy depending upon your architecture. And then from a monitoring, we'll look into two aspects of monitoring. One, with the open source monitoring combination of Grafana, Inflex, and Telegraph for infrastructure monitoring. We will go and install those tools, set up, create the dashboards, and visualize it. And then we'll also learn the AppDynamics. From setting up the AppDynamics, from configuring it with the Java application, setting up the Java agent, and then we'll go and learn what to monitor, how to monitor, how to do the diagnostics using AppDynamics, how to set alerts, how to look into these violations, response time violations, or thread violations, how to take the heap dumps from AppDynamics. So complete monitoring and diagnostics we will learn using AppDynamics. Okay. So once we complete this monitoring, then we will move into your database side. Okay. So from a database perspective, we'll try to learn the database architecture, how Oracle process architecture is designed, what is the memory architecture, and then we'll try to go and see how to take the AWR report, when to take it, how to take it, the thumb rule of taking those AWR report, and then analyzing it from the application perspective, right? From an application perspective, from a SQL performance perspective, we'll try to learn concepts of say buffer cache hit ratio, um, your uh, purely from a application. We are not going to be a DBA. Okay, we should remember that we are not going to go and configure your database or you're going to go and tune your database parameters. No, it is purely from your application perspective. We'll try to learn what to look into AWR report and how to analyze it. Okay, your art parsing, soft parsing, parsing efficiency, buffer cache hit ratio, all these things is what we will learn from a database uh, uh, performance. Okay. So once we do all these things, now you will know in a application, in a project, starting from during a shift left, and then during a testing, monitoring, everything, you will know what to do. Then we'll go and learn how to create an engineering strategy, because we cannot do everything for every time, every project, every release. We cannot do all these things, right? So we need to know when to do certain things. So from an engineering strategy, we'll go and learn how to write an engineering strategy, and when we will be using client-side profiling, server-side profiling, heap dump, thread dump, JVM benchmarking, right? Because in 1 month release or 2 month release, you cannot do everything every time. So from a strategy perspective, we'll go and learn. And the non-functional analysis as well, right? So the difference between the requirement that you gather as a performance tester, it's going to be different from a performance engineer, right? As a performance engineer, you should be looking into a lot of things, right? You cannot just take what the project team is going to give it to you. The mindset of performance engineer is you should go and uh, uh, inquire your business team, your architects, to understand various aspects of non-functional requirements, right? It is just not the critical pages. See, it's a combination of critical pages, frequently used pages, the complex pages, volume intensive pages. There's a lot of aspect you should look into it from a workload perspective. Okay, so non-functional requirements is also from an engineering perspective, we will go and look into it. Okay, and we'll also go through some of the real-time performance issues and bottlenecks, which you might always get these questions in the interview, right? So we'll have a session or two to go over some of these some practical response time issues that we would have faced in a application, the bottlenecks and the root cause as well. Okay. Along with engineering, it's very important for you to crack the interview, for you to be differentiated, to know some of these buzzwords. Right? Today's buzzwords are DevOps, cloud, and the newly born Gen AI, right? So we'll go and learn from a DevOps perspective, performance testing in DevOps. What are the myths? How to actually implement performance testing in DevOps? Jmeter and Jenkins as an example, we will take it, and then I'll explain you what are the important things that you need to consider. What are the real-time issues that you will face when you're trying to bring in performance testing into continuous pipelines? Right. Similarly, we'll also go and learn the cloud concepts as well. What is auto scaling? See, there's a lot of myth around if the application is cloud, performance testing is not required. Right. So we'll try to understand what is the myth around it. In fact, your responsibility is going to be even more from a cloud perspective. So we'll learn what is resiliency, what is chaos, what is auto scaling. Okay, and also we'll go and look into the from an architecture perspective, how these Kubernetes nodes, pods, containers are structured, right? More from you to understand these concepts. It should not be a complete um, uh, black box or gray area, right? From that perspective, we'll have the introduction to these concepts, right? How a Kubernetes application is going to look like. In cloud, what you're going to do, what is resiliency, what is chaos, what is auto scaling. So these things we will learn the concepts so that you'll be ready to get into these projects. Okay. Additionally, as I told, you will get a video of performance automation with Selenium. How we can use Selenium to automate your client-side performance, and also in most of your projects, you are going to have your application servers in Linux, right? So you should be pretty good in Linux from a usage. As an end user, you should be able to connect to a Linux. You should be able to do some monitoring for the Linux boxes. You would be installing the softwares like your Jmeter or other softwares. So from an installation perspective, from a navigation perspective, from monitoring perspective, you should be comfortable in connecting to Linux and then using it through various command line functions, right? So that as well, you will get an access to once you register, you'll get an access to that 8-hour video recording of Linux for performance testers. Okay, so the idea is to get your core from a performance engineering and also get you ready from a future perspective, DevOps, cloud, and then from a Linux environment also you should be comfortable because that is what you're going to do it in your real projects, right? And automation using Selenium. So all these things are all make you yourself more differentiated from others, and practically as well you should know all these things so that you can face the project confidently. Okay, yeah, so that is what you're going to learn. I'll take some questions again to summarize. um, uh, this course is going to be between the same time as we started today. It's going to be 6:30 a.m. to 7:30 a.m. IST, and it's going to be between Monday to Friday, and in some time we'll also have Saturday, but I'll inform you well ahead, 2 to 3 days before itself, if you're going to have a class on Saturday. Okay, and any questions regarding to registration, you can reach out to the WhatsApp group, the administrators of the WhatsApp group, or you can reach out to Kumar sir directly as well. Okay, and the recording of every day will be available to you in the next day, um, or in the evening. If the course is session is happening in the morning, by evening you'll get the recorded video. The recorded video access will be there for you forever. Okay, there is no expiry of that. Okay, and all the softwares, whatever we are going to use it, will be available in the drive. The drive access will be given to you, whoever is registered. Okay. Um, yep. So there are questions in the group. I'll probably take it. We will learn about Jmeter as well. Ankit, we will not learn any testing tool here. Okay. We will use Jmeter for running few of the scripts for e-library application. I might already have a few scripts which I'll be running it so that I'll be able to go and analyze or monitor, right? From that perspective, I'll give you the Jmeter scripts which for the e-library application, which you can also use it, but we will not learn Jmeter or LoadRunner, right? This is not a testing tool related course. So if you want to learn Jmeter, we have other courses which we can recommend you to you. Okay, but you will not learn Jmeter here definitely. Okay, if my application is not Java platform, then also can we use JProfiler to diagnose? No, right? See, JProfiler is for Java. Similarly, there are going to be Python profilers or your Node.js profiler or .NET profilers. Okay, for every programming language, there will be a profiler for specific to that programming language, right? So depending upon your component that is there in your project, you will be able to use those profiler and then find out the bottlenecks. Okay. From a course perspective, we cannot go and touch upon every programming language, as I said earlier. Java being a very common language and very much applicable for every architecture, both from the applicability for your project as well as from your career interview. We have picked Java and then JProfiler. Okay, but you should be able, once you learn this, that conceptually you can scale to other tools as well. If you have doubts, will you do a separate one-on-one session for doubt clearing? We will see one-on-one session for doubt clearing. It's going to be difficult, but say today I have explained you certain things. You're going to go and look into those recorded video again. You're going to practice. So next day, either at the start or at the end, we can have a doubt clarification session. Or in case if you want to after a week, if you have a doubt, we can probably have one day where you guys can join maybe on Saturday or in a weekday itself where I can clarify it, right? So yeah, one-on-one clarification is going to be definitely difficult provided the time availability and all. But we can definitely address that clarification in the session itself for sure. Okay, that if there are any very specific things, is on a case by case basis, probably I can clarify it one-on-one if really required or if possible as well. Okay. Yeah, definitely. After the course completion, the WhatsApp group will be active. Okay, and you can definitely go and ask questions in the group. And while you practice it, see, normally you would be continuing the practice after the sessions are over, right? Definitely you can ask these questions in the group. I'll be able to answer it. And then probably after a week or two, if there are questions, right, we used to have a one session on Saturday after 2 weeks or 2 weeks of the batch is over, so that you can connect and then I can clarify the questions in common. Or if there are any specific questions you get stuck when you are practicing, you can always post that question in the WhatsApp group. I'll be able to answer it. Yeah, definitely. After the completion of the course, if you have doubt, your doubts will be definitely addressed for sure.
And Satish, you mentioned that we can reach you offline as well. So how can we reach you offline?
Yeah, so today and tomorrow, if you have questions around the topics what I have told, to understand whether it is applicable or you or not, to know more about it, I will message in the group now, right? So that you can message me offline in the group or to me separately, and we can connect over the WhatsApp. Okay. After the call is meeting is over, I'll put a message in the group. My name is Satish, so you can reach out to me.
Okay, thank you. And how many days it's going to be covered for this course?
Yeah, it will be around 22, 23, 24, 25 hours. So it will span across 4 weeks approximately. It might be um, plus or minus few days, but it will be close to 23 to 25 hours. Yeah, you can assume that it is going to be 4 to 5 weeks.
Means August last we can complete this course.
Yes, yes, yes. That is what we have planned. By August end, it should get over.
Okay, thank you.
Yeah, we'll get started with the sessions from tomorrow itself, which is your 1st of August. So it should get almost it should get over by month end. Okay, fine. Guys, if there are any questions on the registration, you can reach out to Kumar sir. If there are any questions on the topics, or if you want to know whether, like one person asked about the Jmeter and all, right, you can reach out to me so that I can discuss with you and recommend you if this is the right course for you or not. That as well we can discuss. Okay. Thanks, guys. We'll meet same time tomorrow morning. Yeah, thanks for your time. We'll meet you tomorrow.
Thank you.
Yeah, thank you.
Thank you.